Hello friends, welcome to my YouTube channel. Today I am going to discuss about on a new topic, that is calculation, construction and different properties of Marquette's projection or cylindrical orthomorphic projection. This is the third lesson of map projection series. In the first lesson we had been discussed about polar zenithal stereographic projection, and second lesson we had been discussed about cylindrical equal area projection, which link is provided into the description section. Now we calculate and construct of Marquette's projection. Problem here: draw a Marquette's projection or cylindrical orthomorphic projection for the world map on RF is equal to 1:295,000,000 at 20-degree interval. Calculation. Step 1. Radius of generating globe reduced to given scale R equal to radius of Earth whole divided by denominator of RF. Earth radius is constant, it is 640,000,000 whole divided by denominator of RF is 295,000,000 is equal to 2.17 centimeter. Step 2. Meridians have to be drawn at 20-degree interval: 180 160 degree west, 140 degree west, 120 degree west, 100 degree west, 80 degree west, 60 degree west, 40 degree west, 20 degree west, 0 degree, 20 degree east, 40 degree east, 60 degree east, 80 degree east, 100 degree east, 120 degree east, 140 degree east, 160 degree east, and 180 degree. Step 3. Parallels have to be drawn at 20-degree interval: 80 degree north, 60 degree north, 40 degree north, 20 degree north, 0 degree, 20 degree south, 40 degree south, 60 degree south, and 80 degree south. Step 4. Division along the equator and parallels at an interval 20 degree for spacing the meridian is equal to 2 pi r by 360 degree into cos phi into interval is equal to pi into r means 2.17 whole divided by 180 degree into interval means 20 degree is equal to 0.76 centimeter. Step 5. Height of any parallels above the equator at 20-degree interval is equal to 2.3026 into r into log 10 90 degree plus pi by 2. This is the constant formula. Now we construct the table. The table head as phi r 90 degree plus pi by 2 and 2.3026 into r into log 10 90 degree plus pi by 2. Under the phi caption we write the parallels as 20 degree north and south, 40 degree north and south, 60 degree north and south, and 80 degree north and south. Next, r means radius is 2.17 centimeter. Next, 2.3026 into r is 2.17 log 10 90 degree plus pi by 2 is equal to 55, so is equal to 0.77 centimeter. Similarly, we calculate the remaining heights of the parallels from the equator as 1.65 centimeter, 2.86 centimeter, and 5.29 centimeters. With the help of this table, we draw a Marquette's projection. First, draw a pair of straight lines intersecting each other at right angle. These lines will represent the equators and the central meridian respectively. Next, for spacing the parallels at varying distance from the equator, divide the meridians as per calculation shown in the table of step 5. And draw a horizontal lines through these points to represent the parallels. Then divide the equator at equal space by the equation 2 pi r whole divided by 180 degree into cos 5 into interval for spacing the meridians. Draw perpendicular lines through these points to represent the meridians. After that, erase the extra extended lines and label the latitude as 0 degree, 20 degree north, 40 degree north, 60 degree north and 80 degree north, and also 20 degree south, 40 degree south, 60 degree south and 80 degree south. And also label the longitude as 0 degree, 20 degree east, 40 degree east, 60 degree east, 80 degree east, 100 degree east, 120 degree east, 140 degree east, 160 degree east, 180 degree, 20 degree west, 40 degree west, 60 degree west, 80 degree west, 100 degree, 120 degree west, 140 degree west, 160 degree west and 180 degree of left hand side. Finally, mark the boundary. Put the scale at the bottom. You can draw linear scale like this, or simply put the RF value as 1:2950000000, and also give a suitable title as Markers projection on the top. Also, you can draw the world map like this. Now we discuss about the different properties of Marquess projection. First, all parallels are straight lines and equal in length to that of the equator. Right? This is the first property. And second, all meridians are also straight lines and drawn parallel to each other. Third, all parallels and meridians intersect each other at right angles, means 90 degree. 4. All meridians are spaced at equal distance on the equator. 5. Any straight line drawn in any direction on a Marquess chart passes all parallels and meridians at a constant angle or constant bearing. Thus, it has an advantage for navigation where it is easy for sailing along a series of constant bearing. 6. However, the area property in this projection is greatly distorted. The area lying the higher latitude are shown larger than the true scale. Greenland, being truly 1/10 of the size of South America, is projected even larger than South America in Marquess projection. 7. The poles cannot be shown on this projection. So almost is covered in this topic. If you have any doubt or query regarding this topic, please put it on comment section. I have a look at it. Alright. I hope you found the video informative and helpful. Thanks for watching. I see you very soon.